This is Melissa Alvarado here with the Molecular Modeling Project. The assignment I was assigned was to create the chain and ion calculations, as well as with the end result of that, finding a transition state for the molecule. And the molecule I was assigned was a propane 2-bromo 2-methyl. So to start with the molecule, we'll go ahead and start with the carbon tetrahedral, which is this one. Go ahead and apply it to my new window. Go ahead and open the builder here. I'm going to have to add a bromine to one of these. And just add carbon to this one. And there's the molecule. So what we will go ahead and do is optimize this. So we'll go to calculate, AMPAC calculation setup. It will be an optimization, so we'll leave it at optimization, as well as the AM1 due to the bromine. So we'll submit that, save. I need to create my folder already, so it's right there. And we'll just go ahead and name it. Okay, and save. And then we will be opening the output file. So just press OK there. And there's our optimized molecule. Alright, so what we will do with this, we're going to go ahead and file, we'll edit, copy, and then we'll go ahead and open a new molecule group. Click on the center here to just reapply it. So what we will do here is go to File, New, and this time we'll add a new molecular group. So this will give us this window. And this is a little bigger, and we'll apply a molecule right here in the center. So with these two, we do have two frames here. The second window will be our product window, and our first window will be our reactant window. So right here within our reactant window, go ahead and open the builder. Alright, so in order to go ahead and adjust this molecule, we can't move the electrons around. So what we'll do here, we'll adjust the bonds. Okay, so what we're going to do here is use the bond tool to connect this boron to a hydrogen. So we'll go ahead and make it a single bond and press OK, and then we'll remove the carbon from the hydrogen. So make it a that way the boron is the one connected to the hydrogen and not the carbon. So now between the boron and the carbon, so from the carbon to the boron, we are going to change the number down here, the bond number. So instead of the 1.9, we're going to change this number to a 4. That way it creates a farther distance between the two atoms. So we'll go ahead and press OK. And now we're going to create a double bond between each of the carbons here to give it the balanced electron shell. So double and double red. Alright, and then right here, so that way you'll see in the first pane we have the modifications that we made to this molecule, and the second pane will just be our product that we resulted in. Okay, so in this window, we're going to go ahead and right click, calculate the AMPAC calculation. Close this up here. And then what we're going to do right here, instead of optimization, we're going to go ahead and click chain. Alright, and then within the chain tab, we are going to go ahead and click here on the search for all stationary points along the chain. And right here we'll check the optimization first input geometry and the optimization last input geometry. And we will want to compute the lowest IR frequency, which will make it faster. As well, it will also give us the transition state if it does have one. Alright, we're going to go ahead and submit this and save. Go ahead and within our same project, we'll go ahead and put my chain. So go ahead and save that. And in this case, we will need to open the vis file. Alright, so then after our app pack calculation, this is the result we get. Right here we do notice there are 8 panes instead of just the one. And going through each one, there will be a difference between each of the atoms. And right here we actually did see one of the main, states right before they connect in that single bond between the bromine and the carbene would be at window 5. And it just kind of shows there the disconnection between the atoms carbon and bromine, and then bromine and the hydrogen. So what we'll go ahead and do here, just kind of to illustrate the changes from 1 to 8. Alright. And so what we're going to do now is open the output file of that same result for the chain calculation. So the output file would be this one. We open that. And here we'll show at where the transition state should be. And like I said, it's probably like about 5 because it does match that same illustration. Right click, result. We'll go ahead and view this file. And with this will actually shows exactly where the transition state shows to be. Looking through this information. So we are going to scroll down all the way to here. Let's see. So right here it starts at node number 1, which would be the first pane. And right here it would show us high negative frequency would be the some sort of transition state, and this is node 1. So right here we actually see that it's very low and it's barely negative. So we're going to go ahead into the other nodes to see exactly where everything else stands. So here's node 5, the one in which we had assumed was a transition state. So let's continue scrolling down to the frequency. And yes, so here it does show a negative 2315.149. And then the negative right here just shows the vibrational frequency, which indicates the transition state for this molecule. Alright, so with that proven, we can go ahead and get rid of these right here. So we'll close out the output file. And now from that same folder, we need this file. So I'll go ahead and open this. So under this file, we can go ahead and look to our transition state. And here we are going to right click, do edit, copy this molecule, and then we're going to do a file, new, and create a new molecule group. I'll click right here once more on the center, and then we're going to go ahead and do a calculation for a calculation setup for this as well. And then we're going to actually, instead, we already did the chain, we already found the transition state for this molecule, so now what's left would be finding the IRC. So changing the optimization to IRC, and then we are going to, the direction would be forward, and we're going to click on here and change the step size to a much smaller number, which would be 0.05. We will submit this, save, and we'll give it the name IRC forward, and then we'll give it the transition state, which was 5. and save that. So with this, we will go ahead and open the ARC file. And this will just show in just greater detail, a greater detail extent showing the modifications and the editing behind the molecules between each atom to show the modification of a new atom. And then here, just to see a more vivid results, you can right click, go to result, click on IR path, and it will kind of show us exactly the differences going between the electrons. You can see here at the highest peak, which would be the transition state, and just after that the smoothness going down to change the molecule to reconnect or to disconnect in this case. And it's just kind of a small movie. And that would be my video for my molecular modeling project. Thank you.